Hello guys, today we're going to be doing some more problems with the line of best fit. So in order to do this, let's go ahead and go to Desmos. Again, I encourage you to follow along. We're going to type in Desmos and we want to start graphing. I encourage you to do this on your own computer as we go along. So we want to put this table in to find the line of best fit. So I'm going to go here to the plus symbol and we want to add a table. So I'm going to click table. We have to decide which one's going to be our X and which one's going to be our Y. So we are going to put in latitude as X and we're going to put in July temperature as Y. Notice that we do not need to put the name because that is not our data. So we're going to type in the data. All right, so I typed in all my X's. Let me type in my Y's. All right, so I finished typing in my X's and my Y's. Again, we can't see the data because we need to zoom out. So I'm going to use this zoom out button. I could have also used the mouse pad or the touch screen. So here is my scatter plot. It looks like the scatter plot is going down. And we are trying to find what is the linear equation that represents the July temperature of the cities based on the north latitude. Round the decimals to the thousands, so round 3 decimal places. So we need to come up with our equation, so I'm going to add another tab here. We talked about how our y in this case is y1, so that's exactly what we have to type into here. We got to type in y, and to get the subscript, you can press the keyboard on the bottom, y subscript 1. And again, we are approximating the equation. So to approximate the equation, we need to click this button right here. And it's a linear equation, so it's going to be m as our slope and x. Again, our x is x1, so what do we need to put on this x? We need to put a 1. So I'm going to press the subscript button 1. And we want our y-intercept because it's y equals mx plus b. And here is my equation. Again, we're using this information right here to write the equation. And as you can see, this is the line of best fit that best fits these numbers, and it is decreasing. We will talk about the r and the r squared, our correlation coefficients, later on. But for now, let's focus on the equation. So we are going to write the equation. So let's see, it's going to be y equals, and our m is negative 0.6, whoops, that's not 6, 689, but that 6 bumps up the 9, so it's going to be 0.67 because it wants us to round 3 decimal places. The 6 bumps up the 9, which the 9 bumps up the 8. So it's negative 0.67x plus 53.75. All right, so here is our equation. Now, this problem requires us to do an extra step, and it says, what would be the predicted July temperature at each of the given latitudes below, round to the tenths? So now they're asking me, what is going to be the July temperature, or expected, because again, this line is an approximation, if they give me these latitudes right here, the 25 and 10. So we're going to put in 25 into the equation. So I'm going to have negative 0.67, and instead of x, I'm going to plug in 25 because that's going to be my new x, plus 53.175. And I'm going to use my calculator for this. I'm going to bring out my calculator, and I'm going to type that in there. I'm going to have negative 0.67 times 25 plus 53.17. I'm using my calculator. So the approximated or expected temperature in July, given the latitude of 25, would be 36.4, because they're asking me to round to the nearest 10. So my answer is going to be 36.4. And I'm going to do the same thing for 54. I'm going to type in, I'm going to substitute 54 for x. So I'm going to say negative 0.64 times 54 plus, well, that's not plus, plus 53,175. I'm going to type that into my calculator again. Typed it in there. So my approximated temperature would be actually 17 on this one, because the 9 bumps up the 9, which bumps up the 6. And then I'm going to do the same thing for the 70. And I'm going to write it in the following way. And instead of 54 this time, I'm going to plug in 70. And I'm going to plug that into my calculator. Trying to take some shortcuts here. So that's approximately 6.3 is the expected temperature in Celsius. All right, guys, so I'm hoping that through this example you are able to do number 2 and the rest of the problems on that worksheet. So go ahead and try your best. Thank you.